Okay, so today on assignment 23A, we're going to begin looking at prime factorization. And this is where we take a number such as 24, 20, 27, which come out of your exercises, and we break those down into a product of their prime numbers. So let's look at an example. Okay, let's say that we have a number of 80. We want to break it down into two factors. So there's several examples we could give. We know it's an even number because it ends in 0, 2, 4, 6, or 8. So we could say, well, this is 2 times 40. We know that 8 goes into it 10 times. We know that 4 goes into it. There's other examples we could give. 5 goes into it. But we'll just use these and show that we come up with the same answer. Now, 2 is a prime number because it has exactly two factors, 1 and the number itself, in this case 2. So we're done with this chain here, but we can still break 40 down because it's a composite number, which means it has more than two factors. And 4 could be broken down into 5 times 8 or 4 times 10. Let's go with 4 times 10. Okay, 4, again, is a composite number. It's not prime. So we're going to break it down into 2 times 2. Now 2 and 2 are both prime, so we're done with this chain. And we go here, 5 can be broken down into 2 times 5. So the prime factorization of 80 is 2 times 2 times 2 times 2 times 5. As we would take these prime factors down here and put those in order, and we're going to put 2, that's this one, times 2 times 2 times 2 times 5. 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 10, or 2 times 8 is 16, I'm sorry, and 5 times 16 is 80. Now let's look up here again where we take, give ourselves a little bit more room and come over here. We take this 80, we take the 80, and we're going to break it into 8 times 10 instead of starting with 2 times 40, and show that we come up with the same thing. So 8 is going to be 2 times 4, 4 is going to be 2 times 2, 10 is going to be 2 times 5. So 2, 2, 2, and 2. 1, 2, 3, 4 2's. And then we have our 5 here, and this would be the prime factorization for 80. Let's look at doing another one. Let's say we do 120. Again, there's a lot of different ways we can break this down. We'll show 2 of them and show that we come up with the same prime factorization. So we know that this would be 12 times 10. We also know that this would be 3 times 40, let's say. The 3 is already prime, so this would be, say, 4 times 10. 4 would be 2 times 2. 10 would be 2 times 5. So these are all prime numbers. So the prime factorization, we have 3 2's. We have a 3, and we have a 5. Well, let's say we broke it down into 12 times 10. We're still going to come up with the same answer. 12 could be 2 times 6, or let's go with 3 times 4. 4 would be 2 times 2. 10 would be 2 times 5. Well, I still get 1, 2, 3 2's. I get a 3, and I get a 5. So the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Now you say, well, why are we learning this? Well, for one, it's on the I step. And secondly, it's going to help us in simplifying fractions. So let's say that we had a problem of 65 over 80, and we want to simplify this fraction. So what I could do is I could write the prime factorization of the top number here, the prime factorization of the bottom number, and then I could cancel common factors. So we've already done 80. We know that 80 is going to be 1, 2, 3, 4 2's and a 5. we're going to go 1, 2, 3, 4, 2s, and a 5. The 65, it ends in 5 or 0, in this case 5, so we know it's divisible by 5. If we take 65 and divide by 5, we know that it goes in there 13 times. So we know this is going to be 5 times 13. 13 is prime, 5 is prime, so 5 times 13 is the prime factorization of 65. Well, the only factor that they share is 5, so I can cancel those 5's. On top, I get 13 times 1, which is 13. On bottom, I get 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. So 65 over 80, simplified, would be 13 over 16. Now, it is true that you could write this saying that this is 2 to the 4th times 5, and that this is 5 times 13. But for purposes of right now, for today's assignment, we want you to write these not using exponents. Go ahead and expand them out and write them from least to greatest if you would.